Yes, I'd like to. I was interested that you had mentioned that the NORAD had picked up quite a lot of supposed impacts in the high atmosphere of the Earth, and that they were frequent, and that was kind of confirming the impact rate that you had worked out for size. But I was wondering as well, the Moon would be a particularly good detector as well, right? It's got a fairly large surface area in the right direction. Is there any value in using observations, perhaps satellite observations of the Moon, to detect the rate of impactors and indeed what type of impacts they actually are?
Well, the Moon and the Earth live together. If we want to look at impact rates on Earth, then these surveillance satellites are very good at it. The thing about the Moon is it really is a lot smaller. The cross-section of the Moon is about 1/20th the cross-section of the Earth. So if we talk about something like the KT impactor on Earth once every 100 million years, it's going to be once every 2 billion years on the Moon. And we're very unlikely to actually see anything happen on the Moon. Although they did, the Apollo seismometers that were placed on the Moon by the Apollo astronauts did detect minor moonquakes when meteors hit. But the Moon doesn't really affect us much. We're unlikely to see a big impact, and if we did, it wouldn't do us any harm here. But the Moon also isn't big enough to shield us from much of anything.
Okay, I have a question about the KT impact and also the Permian-Triassic impact and huge lava flows about the same time. I've heard that there's the million square miles of Deccan lava traps in India are approximately the same age as the KT impact in Yucatan and the opposite side of the Earth. And I've heard some speculation that there might be a cause and effect. Or is that taken seriously, or is it considered just a coincidence? And then also related is the even bigger Siberian lava flows that are about the same time as the Permian-Triassic boundary.
The problem with both of those, I mean, it does seem amazing that there should be such a coincidence. The problem is that in both the Siberian case and the Deccan traps in India, the volcanic eruption started between 1 and 2 million years before the extinction and impact in the case of the KT. So the KT impact didn't start the volcanoes. They've been going for some time. I have a hard time thinking that a volcanic eruption series, no matter how big, that was extended over millions of years, would produce a catastrophe in this sort of sudden sense. It'd be very unpleasant for the people, for the creatures living in India or Siberia, but it doesn't fit my mental image of a sudden catastrophic mass extinction. But it's certainly an open issue.
Well, could the Siberian lava traps at some point have triggered a turnover in the ocean so that methane clathrate suddenly melted and released huge amounts of greenhouse gases? And
Maybe. Of course, this is always an interesting question as to whether a much larger greenhouse effect would prove a mass extinction, and maybe we'll find out.
Let's just take the people who are standing.
Okay. I can't see them very well, but we'll take those who are still standing. Nobody else joined the line.
Excuse me, but were there any craters on Mars?
Are there any craters on Mars?
Are there any craters on Mars? There sure are.
Well,
see,
then,
the impacts take place all through the solar system.
Well, then, because I think if there were Martians, maybe they would have died because of the asteroids that hit. I mean, we might be the only surviving creatures in our galaxy.
Well, in our solar system, anyway.
In between the line of Neptune or Pluto and the Sun. In our solar system, we might be the only living things on there. And how can we prevent it? Can we put a rocket inside any asteroids and send them to the Sun or any other place? Or we can blow it apart and blow those small pieces apart?
I'm not sure I understood. Can somebody help me?
How can we protect ourselves from asteroids?
How can we protect ourselves? I wish I knew.
Can't we can't we blow it up?
We could, but you'd have to blow it up with a very big bomb in order to disperse the fragments, to scatter them so that they didn't just hit the Earth anyway. If they all hit the Earth in the end anyway, you haven't gained much.
Damn.
Let me put it this way. I believe, and don't ever trust scientists who say that, I believe that we're smart enough that we could figure out how to deflect an asteroid. But I'm not standing up here and telling you we have the technology right now to do it. I think we can do it. And I think if we were put to the test, we'd make it. But I'm not sure.
Okay.
Dr. Morrison, I'd like to thank you for a very clearly presented lecture tonight. And wonder if you could talk to the factors involved in whether an object attains cosmic velocity or not, and also maybe speak to the Tunguska object, what caused it to explode before it hit the ground.
I didn't talk really at all about the effects of the atmosphere. The atmosphere protects us from small objects because, as I said, they explode high in the atmosphere. The Tunguska object got low enough to do damage, but it still exploded before it hit the ground. And this is exactly what you would expect a stony object to do. These things are coming in extraordinarily fast, 20 kilometers a second. So the time when it first hits the atmosphere until it gets down near the surface is like 4 seconds. And that produces a tremendous pressure on the front of it, and it just comes apart. And all that kinetic energy gets transferred into thermal energy and shock waves. So we think we understand what happened with Tunguska. I do not understand what was going on with that Peru thing last month. So I'm a little more humble today, perhaps, than I would have been a month ago.